Good morning. My name is Andrea Bandelli. I'm the Executive Director of Science Gallery International. It is an absolute pleasure to speak with you this morning. And although I'm not in Amsterdam, I will be connected live after the talks so we can have some questions and discussions about the topic. The presentation I'm going to give is about STEM and STEAM, concepts which are apparently simple, but I found them really difficult and complex to understand and to analyze. And therefore, I want to share with you some of the insights and some of the tools that I've used in my career to make sense of these topics and to make sense of the relationships between art and science in an educational and non-educational context. So this is really a series of suggestions, and I hope they will be as useful to you as they've been to me. For over 2 decades since I've been involved as a practitioner and a scholar of science engagement, I've observed that just like there are many, possibly infinite ways to talk about art and science, there are probably infinite ways to talk about education and practice in what we understand STEAM to be. So I'll present what I found useful in my work, and I hope that some of these ideas may be useful for your work as well. And also I want to thank those who have inspired me to put together these thoughts, and in particular Oren Katz and Ian Brunswick, and the authors of the article The Trouble with STEAM and Why We Use It Anyway, recently published, who you see now on the screen. As it is often the case, it's useful to spend just a few words about the history of the terms STEM and STEAM, because it will become immediately evident that it's not as clear-cut as it may seem. It is important to notice that the terms, indeed, STEM and STEAM, originate in the American education policy discourse. Of course, every country interprets and develops their own education strategies and approaches, and this is definitely not restricted to the American system. But the terms, indeed, STEM and STEAM, come from there, and we shouldn't take for granted that they mean the same things in different contexts. So where does STEM come from? It goes back to the post-war science education overhaul that happened after the Sputnik. This was preceded, of course, by the revolution in science brought by quantum mechanics, the role of the atomic bomb in redefining the relationship between science and society. Sputnik was the wake-up call for the US to think about doing something on science education in school. One visible way then also was through the space exploration, of course, that kind of symbolizes the new role of science, but many other ways. And one that is particularly interesting for us is the birth of the informal science education field. That is usually associated with the opening of the Exploratorium in San Francisco in 1969. That was founded by Frank Oppenheimer, the brother of Robert Oppenheimer, who led the development of the atomic bomb. And the Exploratorium, since the beginning, was always defined as a museum of art, science, and human perception. So the art and science was always indeed part of the DNA of informal science education. Now, in terms of the term STEM, it's interesting to notice that it came about only in the 90s, in fact, when the NSF changed its approach to education and created the Education and Human Resources Division to replace the old Directorate for Science and Engineering Education. And the purpose of this new division was to address education needs across science, mathematics, engineering, and technology, and therefore they had an acronym which was SMET, which wasn't really a great one. So only a few years later, in 2001, somebody had a good idea of changing the order and create STEM, and that is actually was what took off and became incredibly popular. So this is indeed 2001 really is the birth of STEM. And as of STEAM, that actually came to be in 2008 first with a project by the Rhode Island School of Design that wanted to create low to no cost initiative to justify creativity, and then since 2010 it was widely accepted and used as STEAM. Now, STEAM, of course, comes with it critics, but also it is not officially acknowledged and used in any kind of policy. Even in 2015, for instance, we see that STEM is put into law, and actually there is a bill in the US law to integrate other academic subjects, including the arts, into STEM subject programs to increase participation in STEM subjects, improve attainment in STEM, and so forth. But it doesn't mention STEAM, and to this date, indeed, it is not a term that is used in any federal policy. So this is just a short overview and absolutely superficial, limited to one country, but just to show you how it is a construct that is still in development. And what happens is that we use a construct that is central to a country's specific education policy, but it's not officially part of it. We usually transport it to a different country in a different context while it is being discussed and shaped, and therefore indeed you can start to understand that it is a rather complex issue if we dig into it, and central to the definition of STEAM is actually the socio-political construction of education policy. So let's see indeed how to make sense of this, and kind of let's go back a little bit and use this very useful classification of the mutual role between the arts and STEM provided by the article which I showed you just a few minutes ago. And the authors in the article use a matrix with two axes. One is the pedagogical axis, activities that are non-pedagogical, so where the purpose is not educational or for learning, to those indeed that are developed with a specific objective of learning. And on the horizontal axis goes from initiatives where one is instrumental to the other, so there is basically one side is used, say, to attain the goals of the other one, the arts of technology or the sciences, and the other end is where there is this deep integration between the disciplines. So basically the left side, if you want, is the interdisciplinarity, where disciplines can be indeed used to strengthen or to simplify or to clarify, or whereas the right side is the side of transdisciplinarity, where actually new meaning is being made, where the boundaries between disciplines disappear. And before we can see how this matrix is being populated, and on the non-pedagogical side we can have instances where the arts use STEM as a medium for artistic expression. For instance, the field of bioart is usually in this area, where artists use advanced biology and biotechnology techniques to express themselves, or citizen science, where creativity and creative ways and tools are used to pursue scientific purposes. Then we have on the transdisciplinary side, really initiatives that are pushing the boundaries and reject the distinctions between disciplines to create new forms of meaning. And I just want to show you one example that shows how, in this case, data science, computer science, visualization, social sciences, artistic expression, emotional, social situations can be put together to create indeed a very powerful installation. And this is Dataverse by Ryoji Ikeda.
Dataverse is a kind of a conclusion of my data-driven installations and works. Actually, I started to make this kind of works early 2000s. In a sense, it took 16 years to complete. I wanted to try to compose complicated scientific data, which is actually the fact, into a single artwork. I just wanted to understand what is nature, because data is just text actually. The most essential important point is you have to understand the science. DNA, galactic coordinate, the structure of a protein, quantum physics, cosmology. So we got so many big data sets from NASA, CERN, Human Genome Project, but we have to decipher this, what this huge data set is. So 15-year journey was actually to study from scratch because I dropped out of school, But through the project, I kind of understand most of the science, from quantum mechanics, particle physics, to cosmology or astrophysics. Three screens showing at the same time will be the first time and probably the last time. This time is a really special occasion. I can't do anything more than this. Even technically, this is maximum for me now. And 10 years later too, it is really the ultimate version of my computer-oriented, data-driven piece.
So this is indeed an example to show indeed what happens when the boundaries and the disciplines are crossed. And on the top side of this matrix, we find initiatives that are explicitly pedagogical in purpose, and therefore on the one side instrumental we would find more maybe conventional situations where visualizations and design and art is used to explain and to teach scientific concepts, and or where techniques and technology is used to teach arts and creativity. And on the right right top corner are those instances where there is a true transdisciplinary approach to the content with a educational purpose. And those, in my experience, are not only or not specifically single artworks, but this is really the work of institutions and organizations like science museums, science centers, or galleries, where the concept of the exhibition put together with workshops and activities create really that pedagogical envelope, that those pedagogical affordances that make the experience a learning one for the visitors. So rather than artworks being specifically developed with an explicit pedagogical purpose, it is the role of institutions indeed to create this envelope. And useful also in this framework is to look at the epistemology of what we consider STEM, arts, or STEAM. And this comes from also from a recent article by Bronwyn Bevan and others that look at how knowledge is created across three areas, pedagogical areas of exploring, making meaning, and critiquing, to look at the difference between STEM practices, for instance, which are very rational and very much based on inquiry and developing models and analyzing data, arguing, evaluating and confronting. On the arts, there are instead epistemologies based on noticing, on deconstructing elements of criticality, given evaluation that is based indeed on artistic goals rather than on specific measurements. And those in the middle are indeed what we understand as STEAM, and those are not something right in the middle, but actually new ways of making knowledge. And very interesting, for instance, are those that relate to hacking. Hacking is similar to remixing, basically, and to using and reusing concepts and tools from different contexts to create something new. So it's really the creative, a different definition of creativity, but also indeed of cultivating dissent, for instance. And therefore, indeed, there are, if you are interested, there are indeed these tools that allow to understand the epistemology indeed of STEM. Finally, I also want, however, to look at the other side of the practice. So, how are practitioners confronted with STEAM? And I found it very useful a simple but very clear classification that was expressed by Ian Brunswick when he was working at Science Gallery Dublin in 4 areas. And he said one is the interactive science, the instrumentalization indeed of art by science, which we saw before. This is indeed here is explicitly outlined as art making science indeed more engaging and interactive, for instance. Then you have indeed the other one, which is the instrumentalization of science by art, making indeed art that is built on and that uses science to as tools to create indeed new tools. Those indeed would be on the one side instrumentalization, but then you have something really very interesting, which is the role of design as something in between the art and science, and especially the role of design as the canaries in the coal mine, as the precautionary art. Basically an early warning system, a way to look into the future and picture our behaviors, our emotional responses, our social engagement. And here I have just an example to show you how far it can go, and this will lead into the last model which I want to show you. The work you see in the picture here is called Stranger Visions by Heather Dewick Hackbourg. She's a bio hacker, artist, scientist, researcher, and she creates these masks which are constructed using the DNA extracted by things she finds on the street. So basically it's cigarette butts, chewing gums, litter that is taken, extracted, analyzed. There is indeed a whole conversation about privacy and about the data that we leave behind at every single moment, and then indeed the possibility of technology to create something out of the data. It's almost there, not completely. So this is indeed the role of design to picture something in the future. But then I found this video clip which I want to show you, which goes even a step further. So what you see here is really the role of design as a way to show us what if this becomes real. And lastly, the fourth categorization about the practice is indeed that co-curation, that really transdisciplinary approach to create something new, which we usually find in the residencies when an artist is a resident in a scientific institution or the other way around. Lastly, I want to just mention this other way of looking at the relationship between art and science and design, proposed by Oron Katz, who is the director of the Symbiotica Lab at the University of Western Australia, which is a artistic laboratory dedicated to research on life sciences. And Oron Katz talks about the social contract that we have with science, technology, engineering, and design and art. And he says the social contract we have with science is that science makes verifiable knowledge, facts. The truth is the pursuit of truth, so it is not allowed to lie. Art, on the other hand, make sense by making things strange and by provoking and by defamiliarization process by that was theorized by Viktor Shklovsky. So in this regard, art can lie because the purpose is not to make something real, but to provoke thinking about what is real. Technology and engineering, like science, makes something that is useful, makes use of that knowledge, and therefore it is not allowed to lie. And design is actually what works on the behaviors, on making needs and wants and translating the meaning and the tools of technology and science into desires, and therefore it can lie a little bit. And if you think of the project indeed that we just saw, the one in Hong Kong, that is a typical example of design. It is not true, but it is almost true, and it can lie a little bit. And we will never know if it is true or not, but indeed the purpose is really to create indeed those reactions and to test those reactions, which is actually also summarized in this chart by Neri Oxman, that like a clock shows indeed the progress. If you start on the 12 o'clock basically of information going into science, and science creates knowledge, which is then transformed by engineering into utility, into things that work. And then indeed the role of design is to create and to understand behaviors, and that the link between behaviors and art gives rise to new information, because that's the innovation and the role of art to create, indeed, to spark new information that then goes into science. So it's like a circle, indeed, which expresses very well the relationship between these four areas that were expressed by Oron Katz before. And finally, I want to leave you, however, with this scheme, which is very simple but very, very telling, and is the way we still talk about science and art is in different disciplines, and they are still organized as separate disciplines, both in the sciences and in the art. And in fact, what is in between are those really powerful fields of creativity, research, observation, speculation, philosophy, discovery, debate. So that is actually what is at the core of what we may call STEAM, but I just want to leave you with the understanding that it is indeed much more complex and beautifully complex than just adding the arts to STEM education. So thank you so much, and now I'll be more than happy to get your questions and get into conversation with you. Thank you.
Good to see you. Hallo. We gaan ook gewoon over in het Nederlands. Prima. Mensen kunnen hun vragen in de chat voorbereiden. Ik zou jou graag alvast een vraag willen stellen, Andrea. De voorbeelden die je in het filmpje gaf van kunstenaars, dat zijn kunstenaars die heel vaak de grenzen zelf overgaan tussen kunst, engineering, design en soms een klein beetje wetenschap. Maar in zo'n matrix wordt het weer heel erg duidelijk juist uit elkaar getrokken. Hoe zit dat in STEAM-educatie? Zijn de kunstenaars die je als voorbeeld geeft niet eigenlijk al een soort embodiment van dat STEAM-concept?
Ja, goede vraag. Goedemorgen allemaal. Mijn ervaring, en dit is meer een ervaring van de praktijk, is dat er zijn de professionals die wij vaak noemen kunstenaars of designers, zijn eigenlijk een nieuwe soort professionals die hebben kennis en die is echt heel diep in de wetenschap, heel diep in de kunst. En ik vind het eigenlijk moeilijk om ze kunstenaars te noemen, of designers, of wetenschappers, omdat het is echt een bijzondere horizontaal en een heel brede schaal van kennis en abilities, weet je. Dus in mijn lezingen en die artikelen, de bronnen die ik heb gebruikt, de term STEM inderdaad is een beetje questionable. En de basis is dat, weet je, wij strijven voor een multi-transdisciplinariteit die gaat boven de disciplines en de vakken. En daarvoor, mijn ervaring is dat de practitioners zijn daar, zeker qua transdisciplinariteit. En misschien is nog inderdaad de theorie die is een beetje, of wij hebben nog, we vinden het moeilijk om, we zitten vast een beetje aan de concept van de vakken en disciplines. En dat komt ook omdat bijvoorbeeld ik werk met universiteiten en universiteiten zijn nog steeds georganiseerd in disciplines en vakken. En je hebt zelf het gebouw van wiskunde en fysica en de kunsten. Dus het is al, er is een structurele probleem om de echte transdisciplinariteit te bereiken.
Dankjewel. Het is heel helder en ook goede illustratie hoe complex de hele situatie is. Ik heb nog 2 vragen hier van collega's. En de eerste sluit eigenlijk aan op wat jij net vertelde, Andrea. Als we naar festivals wereldwijd gaan, naar het Ars Electronica Festival of dat soort events, dan zien we daar heel veel kunstenaars en ook heel veel ontwerpers, technici, hackers, maar veel minder wetenschappers. Wordt het belang van STEAM wel erkend door de wetenschappers?
Nee.
Oké, daar is werk aan de winkel. Oké, goed.
Ja, nou, hele goede vraag. Nou,
Dat is een heel eerlijk antwoord.
Precies, ja. Nou, heel goed observatie. Ja, ik ben mee eens. Of een beetje dieper te gaan in die antwoord. Ja, mijn eerste reactie is inderdaad... die wetenschap is niet zo duidelijk. Maar het kan ook omdat, nogmaals, inderdaad, zeker in de academische wereld, wij leven nog in een systeem waar in ieder geval een wetenschapper bijvoorbeeld om carrière te maken, moet publiceren in een journal die is super specifiek over een vak. En ik ken ook persoonlijk wetenschappers die, als zij in een andere vak publiceren, of inderdaad in een journal die transdisciplinaire thema's publiceert, dat telt niet voor de carrière. Dus er is ook daar inderdaad een grens en een barrière zeg, voor dat. Dus ik denk inderdaad, er is een structurele probleem. En het is ook een kwestie van generaties. En dat is inderdaad ook alleen puur observaties, maar nieuwe generaties wetenschappers zijn veel meer open en waarderen veel meer de waarde ook van transdisciplinaire STEAM onderwijs dan oudere generaties. Omdat de winst te zeggen en wat zij krijgen is niet alleen specifieke kennis, maar ook al die heel belangrijke skills, weet je, de soft skills of de 20th century skills, of die echte belangrijke aspecten van de ontwikkeling als individu. En die zijn ook belangrijk voor een wetenschapper, net als inderdaad de technische kennis in een specifieke vak.
Dankjewel. Ik heb nog een vraag uit de zaal hier. Jullie doen heel veel indrukwekkende educatieprojecten in de verschillende science galleries. Wat zijn volgens jou de belangrijkste leeropbrengsten? Of wat is de meerwaarde van jullie educatieve projecten in de science galleries?
Het is het concept van agency. Ik weet niet wat is de vertaling in het Nederlands, maar is de capaciteit van meestal jongeren, maar gaat niet per se op leeftijd, om te weten hoe zij kunnen actie ondernemen voor een bepaalde doel. Dus dat is wat nu wereldwijd, zeker in de netwerk van Science Gallery, het accent is. Om activiteiten inderdaad, om de agency van jongere mensen te versterken. En dat is heel belangrijk, zeker om in een wereld waarin vol jongere mensen zijn vaak buiten het besluitproces. Ze voelen, ze zijn inderdaad buiten gesloten. Dus het versterken van die kennis voor een doel, als ik kan inderdaad zo eenvoudig zeggen. Dat is de belangrijkste doel inderdaad van de onderwijsprojecten bij Science Gallery.
Dankjewel voor deze heldere toelichting. We gaan nu even een hele korte pauze houden. Andrea, nogmaals hartelijk dank. En ja, klappen maar voor iedereen.
Bedankt.